Joining us is, of course, Dave Giles, our EV expert, and we are also joined by Al Santini, a valuable member of our education team. I'm sure most of you all know Al very well through all the years of his expertise. So this is being recorded. So anybody who signed up, even if you aren't in this, you will still get notified about the recording. We will also be putting this up on our YouTube channel as well. And just a quick reminder one last time, if you've got questions, go ahead and put them in the Q&A. The chat is disabled, so enter any questions at any time during Q&A, and then at the end of this, we will get to your questions. So without further ado, I'm going to kick it over to the guys.
Thanks, Jimmy. We're going to be starting today's session. Today, like Jimmy says, we have Al Santini with me. We're going to be discussing the EV training checklist, which is a really interesting point to make, especially when you're preparing for curriculum and development and also instruction within your classroom. So I'm going to hand it to Al. Al's going to start us off, and then we're going to move right into the presentation.
Okay, well, good afternoon, everybody. Well, I guess it's afternoon here, not necessarily where you are, but anyway, being on the education team, we hear when we give seminars all the time, I don't have time in my curriculum. There's no time in my classes. There's too much curriculum and on and on and on. We've been between new systems and available curriculum time forever. If you go way, 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 way back, we started in alternators, took over for generators, and drum brakes took over or disc brakes took over for drum brakes, fuel injection for carburetors. Even further back, we got rid of breaker points and we replaced it with electronic ignition. And we had to find time for this. It's nothing new. And the big question always comes up, do we add or do we replace? And obviously, if you said, well, we're going to replace, that's kind of hard to do with EV because unless you're going to start an entire curriculum. So I think it's important to recognize, everybody needs to recognize that if you're going to teach alignment, do it on an EV. If you're going to do brakes, add regen brakes to it. Okay. Suspension, use an EV. CAN bus, use an EV. That's how you begin to put EVs into the curriculum. Okay. I've always been also a believer, especially in today, that we have got other methods to be able to teach certain things. So if you make a list of all of the items that you need to teach, all the topics that you're going to teach in classes, look at it from the standpoint, is there possible there's a different way of teaching a topic that'll free up that time rather than taking a class time? Maybe you can make it a homework assignment. Maybe you're using CDX or one of the other educational systems, and maybe you can take a piece of that and use that and have the students do it on their own time. Okay, think about that. Today we're going to take a look at how do we add or why we should add EV safety. And to be honest with you, it's got to be the first part of the curriculum. Dave?
It's great points that Al's made there, and it's about the integration of electric vehicles into your curriculum. And it's not redeveloping the entire curriculum, it's implementing different aspects of electric vehicles within the existing curriculum. Obviously, high voltage batteries and systems that relate to the high voltage system are going to be their own topic, but they don't have to be an involved, in-depth 600 hours of that type of training, where electric vehicle technology is really only about 10% of the vehicle itself. The vehicle itself still retains all the traditional and conventional systems and steering, suspension, and so on, as Al mentioned, and it's bringing those cars in when you're doing alignment alongside your Malibus and your Toyotas and others that are out there that, that are conventional combustion vehicles, and they're running it with the electric vehicles. And then, and it really comes down to a lot of processes. It comes down to, safety and procedures and following those procedures. And, and I feel that a lot of times when presented with teaching an EV class, which we actually just implemented in Canada. The occupational standard is now implemented within all motive power trades. Electric vehicles is not reinventing the entire wheel. That would be something a lot of people would think that teaching EVs would be like having an automotive instructor now having to teach heavy equipment, which would be a completely opposite side of the automotive trade. Whereas electric vehicles are just another type of power system, just like LPG and light duty diesel engines and so on within our automotive power. So what we want to do today is we want to give you kind of that checklist of things that you need to have in place to making up some of the things that you need to add on into your curriculum without redeveloping the entire curriculum. And we always hear about safety. I'm like inundated with safety. Like I've done presentations and electric vehicle maintenance and repair and service and so on. And it always comes to the forefront of the safety because of high voltage. But the thing that we seem to ignore, and part of that checklist is, when do we use these products? When do we use the high voltage insulated gloves? When do we use, insulation meters? When do I need a Cat 3 or 4 type meter protection? And what do I use them for? What is their purpose and how? And this is a big one, is how do I use that safety equipment and how to use it properly? And we're going to be talking about a couple things that involve both PPE safety, but also vehicle level safety. So within our presentation here, we're going to be touching on these two topics. And so talking about PPE training, we obviously have, our insulated gloves. Now, the thing is, part of our checklist when we talk about the insulated gloves, we got to talk about, what are we working on? When do we use them? In fact, it's a belief that in some cases that the gloves must be worn anytime you're doing any service work to an electric vehicle. And, and anytime you're doing service work to the high voltage system, proper PPE is required. But, the insulated gloves aren't required to doing tire rotations, to doing brake caliper servicing, doing basic maintenance, mechanical services to a vehicle that does not involve high voltage systems. Typically the gloves aren't required. And believe it or not, I have seen personally a shop that was doing some service work on a Nissan Leaf, and they were taking the tires off the vehicle wearing insulated gloves. And, so once again, and that's not the practical application for those. These types of things need to be properly handled, properly tested, and so on. So it's very important that, you have a policy and procedures as well as safe work practices in using PPE. I'm not going to go into depth into each one of these. I'm sure you can reach out to us or myself if you want more information. But, when we start talking about flash protection, I see a lot of schools in that they're buying arc flash gear. They're buying the shields. They're buying the smocks inside. They're buying the coveralls and the jackets, and and buying the mats, and and getting really prepared for arc flash protection. And first thing I ask them, I go, so what level arc flash are you preparing for? And and they look at me and I say, like, so what is your calculation? Are you doing calories per centimeter? What is your arc flash distance? These types of calculations are all part of the policy and procedures as well as safe work practices that should be adhered to within working with the system. And like I said, there's lots of information out there on arc flash and calculations and that, but it comes down to the voltages you're dealing with. If you're working with a 400 volt system, I'm giving an example, within about 20 inches of workspace, you're probably going to need a class 1 arc flash protection. But if you're working with 1,000 volt systems, you're going to need a class 2. And if you're working within 1,500, like in some of the heavy trucks and that now, you're going to need a class 3. So, but if I'm just doing working on vehicles, do I need to buy a class 3 just to cover everything? Well, there's a cost consideration, storage consideration, recertifications consideration with higher class of equipment that you may never need to use. So it's very important to put these things into a checklist to understand what you're actually working with. Secured space, make sure you have the proper sanctions and roped off area and signage and so on. Make sure you have the proper tools to do the tasks that you're going to do in the classroom, like buying high-end multimeters to do tasks that can be done by a conventional multimeter, as long as they meet the safety level within that meter, would be totally acceptable. As well as we always go back to training on high voltage and service. So part of that is it's like taking a gas tank out of a vehicle. If you have a student that you're saying, well, you got to remove the gas tank out of the vehicle, they're not going to go grab a torch. They're not going to be in bare feet. They're not going to be wearing shorts and smoking a cigarette, because you have policies, you have procedures, and
that falls in there.
Well, we hope not. Yeah, that's right. Yeah, exactly. So and these are really important points that we make with the PPE and training. The vehicle side of things is now we have our personal protection and, moving on, but we also have the vehicle side, and the vehicle side is very unique. And a comment I like making is that you really have to know what you're doing in order to hurt yourself. And the vehicle side of protection for high voltage systems cannot be ignored. So meaning that we have to respect the systems that are on the vehicle. We have to understand how these systems work in order to properly service these types of vehicles. So we have things like isolation of the high voltage system. We have our high voltage installation, our LOI, our identification labels, sorry. And of course, we have our high voltage interlock circuits, which really gives a level of protection. Now I'm going to let Al here. He's going to talk a little bit on the high voltage interlock circuits.
Okay, can we make that a little bigger then?
Sure, I can do that, yeah.
Okay, this is not a specific car. It's kind of representative of lots of different vehicles out there. If you wanted the closest thing to this, would probably be a Chevy Bolt. But anyway, the purpose of the interlock circuit is in the name, interlock. What it does is it makes sure that everything is correct before any of the high voltage contactors, which are in the upper center there, HV contactors can close. And if you follow the circuit, you realize it's a series circuit with a 60 ohm, another 1, 2, there's another one, 3, 4, 5, 6, 7, 8, 9. There's 9 60 ohm resistors, which are basically in series. Now that it's a resistance value it's not a specific resistor, it's a resistive value. And what it amounts to is it's saying that there's two ways to look at any circuit. Does the circuit open when something is wrong, or does everything have to be right before it will close? And when you're talking about an HV interlock, it's both. So in other words, all of these 60 ohm resistors have got to make a complete circuit so that we have a small amount of current. Now you notice all the way on the left-hand side where it says 5 volt DC. So this circuit is being powered by 5 volts. So if you put 5 volts as a pressure to a circuit with 6, 7, 8, 9, 60 ohm resistors, you're getting almost no current at all. But the point is you are getting current. So when that current gets back, it's measured, internal measurement, and that's what says there's a complete circuit out there. Without the complete circuit, the system is dead. And that's an important, everything has to be correct before this system becomes lethal or the contactors close and we actually begin to run high voltage. So one of the things to teach is teach students about this interlock circuit and the purpose of it. And don't forget, the easiest way to look at this circuit is says, this circuit, everything has got to be absolutely correct. If it's not correct, it doesn't work. If you look over in the top at SW1, SW1 is open right now. So this circuit's not going to work because you need to have there. Dave just circled it for us. SW1 has to close. All of these individual circuits have got to be closed. SW2 is another one. Something has to close all of these different circuits so that it truly becomes one big series circuit with just a little bit of current flowing through it. We measure that amount of current. And if we come up with the 0, or we come up with 5 volts somewhere, let's say we had down by the inverter in a DC, you got a connection here, IL14 to IL7. If that circuit is broken, then IL14 is going to see 5 volts. There's no current flow. Without a current flow, there's no voltage drop. So, then the computer or the processor knows that there's a problem at the inverter motor. Simple circuit, actually, but has a very, very complicated job to do.
Yeah, and it's a good example of how manufacturers lay this out. And Al's correct, is that, the circuit's being monitored as well. So it sees no voltage drop over example of IL1 and IL2. It knows that there's an open in that circuit. That means something has been disconnected. And based on where it sees, the voltage drops in that circuit, it knows that the integrity of that circuit is good. So in fact, in OEM manufacturer's information, they will have voltage drops at different points in the circuit for testing to ensure the integrity of that circuit. Obviously, resistance within the circuit can also alter it and cause drivability problems and non-functional problems within the high voltage system. So these diagrams are once again a very important part of the vehicle level of safety to ensure that connections aren't being disconnected. So what I have here is just, sorry, I was going to get rid of this marker here, but oops. So you can see here on this sheet, maybe I'll get Al to talk about the how that interlock circuit works on the connections.
Okay, we have the low voltage interlock, and then part of the low voltage interlock are connections that go through the high voltage connectors. That may sound a little bit complicated, but think about it this way. When do we want the circuit to be non-functional? When do we want the system to safely shut down? A, we want it if anything is wrong with the interlock. But B, we also want it if someone goes up and they disconnect a high voltage connector. So what you're looking at is the business end of a high voltage connector there. So there's going to be a jumper. So what we put, or what the manufacturer puts in every high voltage connector will have the low voltage interlock in it. And it's just literally like a shorting bar. You can see where Dave is drawing right now. We have 2 male terminals, and we have in the middle interlocking terminals. Those two, that's a shorting bar. So when we connect these together, it shorts, and that becomes part of the interlock loop. So we have the interlock loop, low voltage side, and then we have the interlock loop, which goes through the high voltage connectors. Interesting, a good way to protect. That way, if a student goes up and decides, hey, wonder what's on the other side of this orange connector. When I pull that orange connector apart, that breaks the circuit and the interlock shuts down the high voltage.
Yeah, and that's even goes for the service plugs on the vehicle. If you're doing a service disconnect plug, when you first pull that lever up, it's actually breaking the interlock circuit before the actual plug gets pulled out of the high voltage connection between the modules. So the interlock is really telling the ECU or the MCUs or whatever the controller is on the vehicle to shut off the high voltage system because we have a break in that system. And I can't remember that term, Al. What was that? What do they call these? It's like a 2-finger single pinch disconnect. It's something really weird. And one thing you'll notice with these connectors are not, and especially if you're disconnecting them, they look complex, and they're not just a simple, push down and release. There's usually a sequence to these connectors. Like one may be you have to push down, pull it back, first stage, then move your finger and then go into a different part of the connector, push that in, and then release it. And this will prevent accidental releasing of connectors on the vehicle. So they do have procedures for that, and there is unique and different types of them. I know some vehicles I'm not used to. I might get a Polestar that comes in that I don't work on a lot of Polestars, and they have a different setup. It's, as it compared to a Lucid, compared to Tesla, Bolt, or Leaf, or Ford. So, they have all these different types of connectors. So sometimes it's good if you find a couple, you can have the students practice with them. And even like the service plugs, they're not just a simple unplug. There is actually a sequence that you have to follow in order to get that service plug undone from the battery pack. In this bottom picture here, I also have one. This is from a Toyota Prius inverter. And you can see within that cover of that inverter, there's actually a jumper. And all this is just really just like a little jumper wire. And this ensures that, the cover is in place before it allow the high voltage system to engage. So to point in case, a high voltage interlock, hence its name, high voltage interlock, is actually part of the low voltage system. It's a controls device used to control the high voltage system. So once again, just a kind of a quick overview of how we have safety measures within the vehicle to protect anybody from messing around or not knowing what they're doing. So like if you take this cover off, the Prius is not going to operate because of that switch that's there, or the connection that's broken, which is part of the HVIL. Anything else there to Al?
No, I'm okay.
Okay, and one other thing I wanted to point out too is one thing you'll notice, I use this diagram, see these pins here, the high voltage pins? One of them is actually longer than the other. And it's another sense of how they control the disconnecting of the high voltage system to prevent arcing and so on. So once again, you may see that one of the terminals here is longer than the other terminal in those high voltage connectors. So, obviously one's being positive, one's being negative. So I'm not going to give you the answer, but just think about disconnecting a battery on a vehicle, which terminal you disconnect first. So anyways, I'm going to move on here. And our time's getting a little short. I want to leave it open for some questions at the end, but here's another big thing that is a big misconception with electric vehicles is isolation. I know there's an isolation circuit within the vehicle. We call it LOI, loss of isolation. It's monitored through the vehicle chassis, through the low voltage system as well. But it's monitoring for high voltage leakage within the vehicle itself. That means that the battery pack, the high voltage battery pack, has nothing to do with the chassis of the vehicle. It is a completely independent system in the vehicle. So if I was to take the positive terminal of the contactor right now and put a jumper wire to the chassis of the vehicle and attach it and turn the car on, nothing would happen other than it would set a code and shut the vehicle down because it would see that there's a short. It won't burn the wire. It won't, cause any other issues other than it sets the code. In fact, if I take the ground cable and attach it to the chassis of the vehicle, now I don't have that isolation anymore. I am now connected to the vehicle. And of course, within this module, the fuse would blow instantly. So the protection within the vehicle itself, it has redundancy within that system to do that. In fact, it would be almost impossible because the covers also have HVIL in them. The way we like to think about isolation is I put a cordless drill in the back of one of our EVs here, and it's like I can pull the trigger on this cordless drill, the drill works, The battery and the drill have nothing to do with the vehicle. And that's the same way with the high voltage system on an electric vehicle. Yes, the low voltage system controls the high voltage, but the high voltage has nothing to do with the drive unit and the inverter and so on with that vehicle. So essentially the high voltage powers the electric motor, just as my battery on my drill powers the electric motor on my drill assembly. So it's once again, so if you happen to touch the high voltage positive side and touch chassis ground, essentially nothing will happen. In fact, we have case studies that. Do we recommend it? Do you do that as a demonstration? Absolutely not. But the thing is, understanding what isolation is and how it works better handles, because that is not a procedure you would ever do. If I have this cover off the vehicle, I'm going to have my proper PPE and I'm going to follow the proper procedures when dealing with the high voltage vehicle. If there is ever an incident, the vehicle has its level of protection as well. Do you have something there, Al?
No.
Okay.
How about some questions?
Yeah, sounds.
So we do have 2 questions, and I'm actually going to tee one up for Al and one up for Dave because they seem perfect for each of you. The first question is teed up for Al. This is coming directly from Mr. Books. He's got his entire Auto 2 class at Forest Hills High School in North Carolina watching as we speak. And this is probably more of a generic question, but I know it's perfect for you. He wants to know, where should his level students at the high school level Auto 2 start?
I would say to start with safety, okay, and make sure that everyone is aware of safety. A good thing I think to introduce, I got to get the right. Dave, is it called EV Rescue?
Yeah, I do have a few.
Yeah,
Here you go.
EV Rescue is a good example of something to start with students. Everybody can put this on their cell phone. And as an instructor, you could even make an assignment, say, okay, I've got somebody with a 2023 Ford Mustang Mach-E GT. How do we shut it down? If we're going to work on the high voltage system, how do we shut it down? So safety becomes one of the first things to teach. And then add into, when you teach brakes, you do a little bit with regen. When you go and you teach suspension, using EV. So try to use the EVs if you have access to them, and that's obviously an important thing. But safety, number one.
Yeah, and I like to add too, as well as is understanding the fundamentals, like understanding basic electrical, like Al said, mechanical. Never forget your fundamentals. It is paramount in all vehicle systems. So once you understand, how the operation of hydraulics works, understand how different types of circuits work and so on, it makes so much easier when new technology gets introduced to us. So.
Perfect. And this question I'm going to shoot toward Mr. Giles because it seems pretty heavy. It's definitely over my head, but that's not saying much. Has destructive testing been done in controlled environments to simulate and analyze arc fault events on lithium-ion batteries? What are the incident energy levels we are seeing for these lithium-ion batteries? Are manufacturers providing incident energy labels?
So right now, it's 2 things that have to happen. One, you have to understand the environment you're working within and the type of connections you're dealing with. Because you have vertical connections, you have horizontal connections. You have to deal with the voltage levels that you're exposing yourself to. Has testing been done? Definitely, testing's been done within different voltage levels. That's how they get NAFTA 70E gets the classifications. It's a double E. 19803, I believe, is the standard. But what I really recommend, I'd love to do one on arc flash safety, because there's calculators out there. Great for students to even understand how arc flash is calculated. both with using Ohm's law and then going into the calculators that you understand the distance you're working with and the voltage you're working with and the area of securement. Are you working within the module? Are you working exposed from the module? Are you working on vertical type of connectors? Are you working on horizontal connectors? So these are all things that get factored into that calculation. Sometimes you might get an arc flash of level of 0, which means you don't need it. That means the arc flash is so minimal that you literally have to be kissing it to have any kind of incidents. But when you're into level 1, level 2, and level 3, there's only 4 levels of arc flash out there. So if you're working with, and most automotive is going to be around a level 1 arc flash. So if you have arc flash protection of level 2, you'll be completely good. For most automotive applications, I'll take you right up to 600 volts as well. But once you start moving into different environments and different types of batteries and stuff like that, some batteries are more exposed than others. Some of them you have to reach down inside to get at, to disconnect modules or even recommission a battery by its contactors and activate it. That's where the arc flash will start coming into play. But good questions. But there is a lot of information online about, and I'd like to caution you, if you are looking up arc flash stuff, make sure you punch in DC arc flash. Especially if you're working with battery modules. So DC arc flash, essentially the calculator is the same. The calculation comes out the same, but it just, puts it more into the automotive aspect of doing that calculation. So
here's another interesting question in a world we don't frequently talk much about. If teaching an auto body class, we don't teach about brakes, should we teach regen braking on its own? What are some other important areas I need to introduce to students in the world of auto body?
Interesting. I'm right after this call, I'm actually being interviewed for Body Shop News on EVs, and it's a great question. And it's understanding the systems. I think for auto collision shops and body shops, it's important to understand the different systems, the safety. What Al mentioned there about this rescue app, which is fantastic. Collision shops are more involved with electric vehicles. One, they see them before anybody else sees them. Two, they're in situations that have not really been engineered by manufacturers, like, whether it's an impact on the side, maybe partially flooded vehicle, things like that, pose some sort of, more inherent risk at that point. So, talking about systems like regen braking is part of a strategy within the electric motor, the drive units, the MG. So, so the conventional braking system would be the same, but maybe understanding what is regen braking, what does an inverter do, what does a DC do, what cables carry high voltage, what systems store high voltage, and that would be really good for a collision program to introduce that to students. This way, when they see something, the battery's out of the vehicle, but they still see orange cables, they know that those cables only carried with that high voltage battery supplied. So it makes them feel more at ease in understanding those types of systems. So.
Yeah, the first thing in these body shops is the students that are being taught have got to know how to disable the system, have got to know how to open the interlock circuit, and follow the procedures. Some of the procedures involve you open a particular connector and it's got a hole in it, and you put a lock or a clip or something on it to make sure that nobody else comes along and can energize it again.
We had a good comment as well from Kurt Ward at Joliet Junior College, who's watching. He answered as well and said, look at the ASE Education Foundation standards. The collision standards were updated last year to include high voltage safety. So that's always good advice as well from Kurt there.
Yeah, any information that's out there, always reference back to, like up here in Canada, we have our SOS. Down in the US, they have ASE. So, and they're always like, it's not like they're always on the forefront to try and keep, information flowing. Lots of stuff out there. A lot of conferences are going on now, all focused around high voltage vehicles. So it's, so once again, there's lots of information, lots of things happening to help prepare the industry for, the influx of electric vehicles, because there's a lot on the roads now and they're coming out of warranty. More of them are getting smashed, more of them are getting damaged, and a lot of them are getting higher mileage on them. So now we're going to start seeing more and more of them in for repair. So
another comment, not so much a question, but as a good thing to bring up. Jeremy Merritt here says, all this seems really familiar coming from the electric forklift world. Everything is basically the same system. So if anybody's worked on those, he said it looks awfully familiar.
Yeah.
I couldn't agree more. We always talk about electric vehicles being new technology. 1800s they had electric cars. Now they may have not had the isolation and the interlocks and stuff, but they work the same way. And you're right, forklifts and mining equipment that have been around for a long time work very similar to today's electric vehicle system. So
we have gotten through all the Q&As. So before everybody jumps off, I want to make sure you mark your calendars for 2 weeks from today, May 29th. We're having another webinar. This one, I'm not going to deceive you, is going to be a little more of a sales focus, because ConsLab is launching one of our most revolutionary products we've launched in many, many, many years. Dave Giles and our entire education team, along with all of our engineers, have worked really hard to make sure this thing is going to achieve exactly what we wanted to achieve. And ironically, it's about high voltage disconnect. So May 29th at 1 p.m., we will be promoting more about this, but you definitely want to see what we've got cooking here. Right, Dave?
That's right. It's really, and don't forget Al. Al was a big part of this this product, so it's really cool.
Al wrote the curriculum, yes?
Yes, he did. Yes.
Writing. Let's not make it past just yet.
Yes. So
that's great.
That will conclude our time here. We do appreciate everybody once again. Shout out to those students. We always encourage you to have your class listen in. Hopefully they found it entertaining and educational. And like I said, May 29th, we will be launching the EV400 Disconnect Trainer. You will definitely want to see this.